Hello everyone. Welcome back to my YouTube channel. Today we will discuss important questions based on thermodynamics. If you like my video, please like, share, comments, and subscribe to my YouTube channel. Now, let's see the questions. So, the first question is, state the zeroth law of thermodynamics. So, the zeroth law of thermodynamics states that if each of the two given systems are in thermal equilibrium with a third system, then the two given systems are in thermal equilibrium with each other. Example: a hot cup of coffee kept on the table. At first, a hot cup of coffee is not in equilibrium with its surroundings, because its temperature is higher than the surrounding, so that it will be cooling off, and its temperature will be decreasing. But once its temperature stops decreasing, it will be at room temperature, and it will be in thermal equilibrium with its surroundings. Now, next question is, what is the Joule Thomson effect? So, the phenomenon of producing lowering of temperature when gas is made to expand adiabatically from a region of high pressure into a region of low pressure is known as Joule Thomson effect or Joule Calvin effect. Hence, Joule and Thomson showed that when compressed gas is forced through a porous plug into the region of high pressure to a region of low pressure, there is appreciable cooling. Now, next question is, what is internal energy? So, the energy stored in the system by virtue of the configuration and motion of the molecules constituting the system is called its internal energy. The energy due to the motion of the system, that is the kinetic energy, and that due to its external position in a gravitational, electrical, or magnetic field, that is the potential energy, are not included in the internal energy, because this energy are of due to mass of the system. But the molecules constituting the system possesses kinetic energy of translation, rotation, and vibration. They also possess potential energy due to the forces of attraction existing among them. This molecular, potential and kinetic energies contribute to the internal energy of the system. It is a definite property of the system, and is denoted by A or U. The SI unit for the internal energy of a system is the joule. Another unit of energy is the calorie. And 1 calorie is equal to 4.184 joule. Now, next question. Is internal energy a state function or path function? So, the internal energy of a system is a state function. Example: the heating of 1 mole of liquid water from 0 degree to 100 degrees Celsius. During this, the change in energy is 1.8 kilocalories. And this energy will be the same, regardless of the form in which this energy is transferred to the water. By heating, by performing work, by electrical means, or in any other way. Hence, internal energy is a state function. Now, next question. Is internal energy is intensive property or extensive property? So, internal energy is an extensive property. Since the value of internal energy of a system depends on the mass of the matter contained in a system, hence, it is an extensive property. Now, next question. What are the sign conventions used for internal energy? So, in thermodynamics, we are concerned only with the energy changes when a system changes from one state to another, because it is neither possible nor necessary to calculate the absolute value of the internal energy of a system. Hence, if delta A be the change in energy, and An is the energy of the initial state, and AF is the energy at the final state, so we can write delta A is equal to AF minus An. So delta A is positive if AF is greater than An, and delta A is negative if AF is less than An. Now, next question. What is the first law of thermodynamics? So, the first law of thermodynamics is an application of the law of conservation of energy to the thermodynamic system. Hence, the first law of thermodynamics states that although energy assumes many forms, the total energy of an isolated system remains constant, though it may change from one form to another. This law of thermodynamics may also be stated as the net energy change of a closed system is equal to the heat transfer to the system minus the work done by the system. Now, next question. Is the first law of thermodynamics applicable to irreversible process? Yes. The first law of thermodynamics applies to the irreversible process, and it is also applicable to all types of processes that mean reversible and irreversible process. Now, next question is, what is a mathematical equation for the first law of thermodynamics? For a system undergoing a cyclic process, the first law of thermodynamics states that the algebraic sum of work interactions is equal to the algebraic sum of the heat interaction. Hence, integration of dq is equal to integration of dw. We can write this as integration of dq minus integration of dw is equal to 0, where integration of dq is net heat transferred during the cycle, and integration of dH is net work transferred during the cycle. Hence we get integration of dq minus dw is equal to 0. du is equal to dq minus dw. Now, next question. What is the mathematical equation for the first law of thermodynamics for the isochoric process? As we know, the mathematical equation of the first law of thermodynamics is du is equal to q minus w. So for the isochoric process, work of expansion is 0. Hence W is equal to 0. Hence equation of first law of thermodynamics for the isochoric processes, du is equal to q. Now, next question is, what is the mathematical equation for the first law of thermodynamics for the adiabatic process? So, as we know, the mathematical equation of the first law of thermodynamics is du is equal to q minus w. But for the adiabatic process, there is no change in heat gained. Hence, q is equal to 0. Hence equation of first law of thermodynamics for the adiabatic processes, du is equal to minus w. Now, next question. What is the mathematical equation for the first law of thermodynamics for the isobaric process? As we know, the mathematical equation of the first law of thermodynamics is du is equal to q minus w. So for the isobaric process, pressure remains constant. Hence, work done, that is W, is equal to P into delta B. Hence equation of first law of thermodynamics for the isobaric processes, du is equal to q minus P into delta B. Now, next question. What is the Gibbs phase rule? So, the Gibbs phase rule gives the degrees of freedom of the number of independent thermodynamics properties of a system. These properties are intensive properties. So, according to the Gibbs phase rule, the number of degree of freedom, that is F, of a system is F is equal to C plus 2 minus P, where C is number of independent variables, P is number of phases. Now, next question. What is degree of freedom? So, degree of freedom is defined as the least number of variable factors like concentration, pressure, and temperature, which must be specified, so that the remaining variables are fixed automatically, and the system is completely defined. It is represented by F, and can find out from the Gibbs phase rule. A system with F is equal to 0 is known as no variant, or having no degree of freedom. A system with F is equal to 1 is known as univariant or having 1 degree of freedom. A system with F is equal to 2 is known as bivariant or having 2 degrees of freedom. Now, next question. What is the degree of freedom at the triple point? So, as we know that a triple point is the conditions under which all the three phases, that are solid, liquid, and vapor, can coexist in equilibrium. So at the triple point, solid is in equilibrium with the liquid, and these two phases are also in equilibrium with vapor. Hence, according to Gibbs phase rule, F is equal to C plus 2 minus P. But in the given system, only one component, that is water, present. Hence C is equal to 1. And there exists three phases, which are solid, liquid, and vapor phases. Hence P is equal to 3. Hence we get F is equal to 1 plus 2 minus 3, which is equal to 0. So, at the triple point, we get F is equal to 0, which means that the system has no degree of freedom, and hence the system is non-variant. Now, next question. What is the degree of freedom of saturated liquid? So, if the substance is existing as a saturated liquid, it is in equilibrium with its own vapor. Hence in the given system, the liquid is in equilibrium with vapor. As we know, according to Gibbs phase rule, F is equal to C plus 2 minus P. But in the given system, only one component is present, which is water. Hence C is equal to 1. And there exists two phases, that is liquid and vapor phases. Hence P is equal to 2. So we get F is equal to 1 plus 2 minus 2, which is equal to 1. So for saturated liquid, we get F is equal to 1, which means that system has 1 degree of freedom, and hence the system is univariant. Hence only one intensive property can be specified for the complete description of the state of the system. Now, next question. What is the degree of freedom of saturated vapor? So, if the substance is existing as a saturated vapor, it is in equilibrium with its own liquid. Hence in the given system, vapor is in equilibrium with the liquid. So, according to Gibbs phase rule, F is equal to C plus 2 minus P. But in the given system, only one component, that is water, present. Hence C is equal to 1. And there exists two phases, which are liquid and vapor phases. Hence P is equal to 2. Hence we get F is equal to 1 plus 2 minus 2, which is equal to 1. So for saturated vapor, we get F is equal to 1, which means that system has 1 degree of freedom, and hence the system is univariant. Hence only one intensive property can be specified for the complete description of the state of the system. Now, next question. What is the degree of freedom of liquid water which is equilibrium with water vapor and nitrogen? So, the given system is liquid water which is in equilibrium with a mixture of water vapor and nitrogen. Hence, liquid water is in equilibrium with water vapor, and it is also in equilibrium with nitrogen. So according to Gibbs phase rule, F is equal to C plus 2 minus P. But in the given system, two components, that is water and nitrogen, present. Hence C is equal to 2. And there exists two phases, which are liquid and vapor phases. Hence P is equal to 2. Hence we get F is equal to 2 plus 2 minus 2, which is equal to 2. So for a given system, we get F is equal to 2, which means that the system has 2 degrees of freedom, and hence the system is bivariant. Hence two intensive properties can be specified for the complete description of the state of the system. Now, next question. What is mean by the enthalpy of a system? So, the enthalpy of a system is the total heat content of the system. Hence, the total heat content of a system at constant pressure is equivalent to the internal energy A plus a product of pressure and volume. It is called the enthalpy. It is denoted by H. So, according to the definition enthalpy, H can be written as H is equal to U plus PV, where U is an internal energy, P is pressure, and V is volume. Now, next question. Is the enthalpy is a state function? So, from the definition of enthalpy, H can be written as H is equal to U plus PV, where H is enthalpy of the system, U is internal energy of the system, P is the pressure, and V is the volume. As we know that, in this equation, internal energy, pressure, and volume are all state functions. And the value of enthalpy depends on the values of internal energy, pressure, and volume. Hence, enthalpy should also be function of state. Hence, enthalpy is a state function, and its value is independent of the path by which the state of the system is changed. Now, next question. What is the molar heat capacity of a system? So, the molar heat capacity of a system is defined as the amount of heat required to raise the temperature of 1 mole of the substance or system by 1 Kelvin. It is denoted by C. So according to definition, C is equal to dQ by dt. Thus the molar heat capacity may be defined as the ratio of the amount of heat absorbed to the rise in temperature. Now, next question. What is the molar heat capacity at constant volume? So, the molar heat capacity at constant volume is defined as the rate of change of internal energy with the temperature at constant volume. So, according to the first law of thermodynamics, dQ is equal to dA plus P dV. Now after dividing both sides by dt, we have dQ by dt is equal to dA plus P dV divided by dt. Now at constant volume, dV equals 0. Hence the equation reduces to CV is equal to dA by dt at constant volume. This is the equation of molar heat capacity at constant volume. Now, next question. What is the molar heat capacity at constant pressure? So, the molar heat capacity at constant pressure is defined as the rate of change of enthalpy with the temperature at constant pressure. According to the first law of thermodynamics, dQ is equal to dA plus P dV. Now after dividing both sides by dt, we have dQ by dt is equal to dA plus P dV by dt, which is equal to dA divided by dt plus P dV divided by dt. Now as we know from the definition of enthalpy, H is equal to A plus PV. So, after differentiating this equation with respect to temperature at constant pressure, we get dH by dt at constant pressure is equal to dA by dt at constant pressure plus P into dV by dt at constant pressure. If we compare equations 1 and 2, we get Cp is equal to dH by dt at constant pressure. This is the equation of molar heat capacity at constant pressure. Now, next question. What is the relation between Cp and Cv? So, as we know from the definition of molar heat capacity at constant pressure, Cp is equal to dH by dt at constant pressure. And from the definition of molar heat capacity at constant volume, Cv is equal to dA by dt at constant volume. Now, from the definition of enthalpy we can write H is equal to A plus RT. So after differentiating with respect to temperature, we get dH by dt is equal to dA by dt plus R. So by comparing equations 1, 2, and 3, we get Cp is equal to Cv plus R. Hence we get Cp minus Cv is equal to R. So, that's all about questions on thermodynamics, which is mostly related to the first law of thermodynamics. In the next video, we will discuss questions on another topic. If you like my video, please like my video, share this video with your friends, and subscribe to my YouTube channel.